Good afternoon. I have the pleasure to moderate a panel discussion on digital twin and the metaverse to transform the infrastructure industry. We have seen already various presentations about the metaverse and about the digital twins. And this afternoon, we will have the opportunity to see 3 different examples of implementation of digital twin on the engineering industry, and in particular, we will have Eric Desroches from Autodesk Design Solutions, the director of the infrastructure business strategy, Eric. We have Serge Lupas from Ciclomedia, the CEO of Ciclomedia, and Luc Dehaene, that is replacing Gerd de Conseil, that is the Chief Customer Office of Mercator. The 3 panelists have been selected because you will see the differences in the vision and the difference in the challenges related to implementation of digital twin for different applications and goals. We had some discussion this morning about what is a digital twin. In the section moderated by Mark this morning, it was very clear that a clear definition of digital twin is missing. There is a lot of, I would say, pressure to have the good data that are needed to develop digital twins. But when I look to the origin of digital twin, and everybody knows that in '91 there was a book written by David Gentelers that was called Mirror Worlds, in which the concept of digital twin was, in a way, formulated. A formal definition was given in 2002 by Greaves, and then one of the first implementation of digital twin was made by NASA in 2010, when they developed a digital twin for space capsule simulation. So they were using really to see how these capsules are reacting to different stress. So this is the concept of digital twin dealing with the replication of an object, how this object works, and what we have to do to make sure that it's working properly. But there is another stream that I still consider addressing the digital twin. And this was basically in the book of US Vice President Al Gore in 1992, Earth in the Balance, when he was thinking about what we can do if we have a digital replica of our planet. And some years later, in 1999, he formulated the concept of digital Earth. Digital Earth is, for some of you, very similar to the idea that you have as a digital twin. It's a digital replica with all the geospatial data integrated. So these 2 are really 2 examples from digital twin as an object, as a replica of an object, or digital twin as a replica of the systems. And according to where you apply the concept of digital twin, you will see that the challenges are completely different. But I don't want to consume more time. I leave now to Eric to start.
Thank you, and good afternoon, everyone. The topic I wanted to speak to you today regarding digital twin is really through the lens of the AEC community. So think of architects, civil engineers, and contractors, the industry that's responsible for our built environment. Now, I'm obligated to show you this slide. It simply means don't make any purchasing decisions based on what I'm going to share with you. It's a good time to be serving the AEC industry today because we have a tremendous demand. You've heard us talk about population growth, urbanization, the need to not only build new, but to also retrofit existing infrastructure. And many of our governments around the globe are using stimulus funding to now close the gap in spending on those assets. But the way in which we work has also changed, and certainly the pandemic has accelerated that with the remote workforce and what we have today. But also all around us is digital technologies emerging and emerging at a very fast pace. So our industry of AEC is going through what we call a rapid digital transformation. And why is that necessary? It's necessary because if you look at the last 50 years, very little technology has been brought into construction to improve our productivity. It lags behind other industries like hunting, fishing, and agriculture, for example. So today, data is all around us, and it's in demand by the owners and the community at large. Over 95% of all data is going unused, however. We lack the necessary methodology to preserve that data across the life cycle. So we're going through this digital transformation, but it's nothing new. We've been on this journey for over 40 years, and it will continue. And the way we like to describe it is we went from the analog world to digital with CAD years ago. Then we went to BIM, Building Information Modeling. And the key here is that the BIM process is really the enabler to the digital transformation. And today we're on what we call BIM 2.0, which is really the power of the BIM process coupled with cloud and collaboration. So if BIM is really the backbone of this digital transformation we're forming, when it comes to digital twin, it's really the outcome or the deliverable that you see across the entire life cycle. And the way we deliver that experience today, you'll hear us talk about things like digital project delivery. So it evolves around concepts like common data environments, collaboration in the cloud, interoperability between different software products and the like. And the reason for that is that we've been on this sawtooth curve for many decades now, where it's been very difficult for data handover between the different phases of the life cycle and data loss. And so really we're aiming for the top curve of a smooth data flow. But today it's very sequential, it's very disjointed, and it comes to a final end. So the BIM of tomorrow and the process of tomorrow will be very much centered on data at the center and a collaborative platform type environment. And again, if you look at this, you can see that what will this drive in terms of the frictionless movement of data between different providers and different types of information as well. And actually the digital twin and all of the AEC environment that we serve is really a system of systems. You can no longer design and build a building, isolate it from the local environment, and not understand how it's connected by roads, rail, water systems, and other utility systems. So we're looking very much at a connected system of systems. And so what's going on within the industry today is the definition of what we call information models. And that information model just isn't BIM itself. It's also bringing in other spatial data such as GIS. It's connecting sensors to all of our physical assets so you can capture real-time data. And there's a lot of context capture or capturing of the existing conditions. And you see many of those companies out there on the floor today that are doing this type of work. And really, if you look at this report from ENR, it says that as digital twins become more defined and more prevalent within our AEC industry, it's going to actually change a lot of our requirements in terms of data interoperability, data sharing, and the like. And it's also going to disrupt our industry from the standpoint that you're going to see different building or business models evolve. You're going to see different returns on investment for organizations and owners investing in this type of technology. And you're going to see it become a real-time system of record in terms of the asset itself. And then, of course, it will also drive future opportunities. But if we look at the digital twin today, we've got a long ways to go in this maturity curve to increase the business value. Arguably, we're on the left-hand side here with traditional digital models, but eventually we'll move all the way to autonomous and self-governing models. And really, the way to think of it, it's a full life cycle journey that we're on. It's not only about building new assets, it's about renovating the existing assets. It's about bringing all the spatial data you can think of together to solve this problem for AEC. And certainly much of that will be driven by the convergence of technologies too, such as BIM and GIS. Thank you.
Thank you, Eric. Very interesting and matter for good question. Now we move to Serge, that will present from a different perspective.
Thank you, Alessandro. Hello, everybody. Thanks for being here. We were discussing with Alessandro what's a digital twin, and in the end, what's at the core of a digital twin is a model that can be used also later on to monitor things, to plan things, to change things, but it's a model, and the model has to be accurate. If it's not accurate, you can't use it. Hence, true to life, accurate data is a prerequisite for building digital twins. And that's what, in the sense of GIS, Cyclomedia is doing. We are digitizing the outside world on a very large scale with high fidelity in 3D. Why do we do that? Because we can then visualize, map, and analyze what has been captured and digitized. And that allows our users to make data-based decisions that are better, that are accurate. So building accurate digital twins is something that is at the core of what Cyclomedia does. Street-level data in very, very high accuracy, positioning accuracy, as well as the resolution, and allowing Autodesk engineers using Autodesk to have the right input to build their models, allowing infrastructure managers to know exactly the state of their infrastructure. And then talking about IoT data and all the myriad of sensors that are now being placed, exponentially placed in nature everywhere. Well, if you don't know where that signal, that information comes from, if you don't know exactly where it's located, it's no use. So being able to have a very precise canvas, a very high accuracy canvas, to place all this information, additional layers and layers of information is key. That's what Cyclomedia does, and I'm happy to bring that vision and that part of the vision to the discussion today. Thank you.
Thank you. Now we move to the last introductory speech from Serge.
Good afternoon. My name is Luc De Heijn. I'm the Chief Commercial Officer for Mercator, replacing Geert de Koensel. I'm very happy to be here on stage with big names like Cyclomedia and Autodesk, but I think that Mercator is quite unknown for a lot of you. We strive to have operational excellence for the telecom and utility network operators through the power of a digital twin. And in my presentation, I will quickly highlight where we come from and what we mean with that digital twin, and also with operational excellence. We were founded in 2008, where we are focused about geospatial services. We were helping the telecom and utility network operators with the GIS systems, integrations, and so on. But we quickly noticed that many of the applications are aging, are not fit for the needs of today. And so in 2011, we started developing our own software from our hub in Brussels. In 2019, we also had added some capacity in Spain. And we also noticed that many of our customers don't only need the geospatial services or the geospatial software, but they were missing one key component, and which is the data. And so we had the opportunity also last year to acquire the leading data provider in Belgium, geospatial data provider, which was GIM. And together we offer the SDS toolkit, software, data, and services. So what is a digital twin? And when we discussed this topic with Alessandro, I showed him one of the images that clarified why are we in this market. And it's the ostrich. We do not have a data quality issue. When we go to our customers, many of the high-level people in the room will say, indeed, we do not have that issue. For us, the data is good enough. Everyone is responsible for good data quality. But you all know what happens when everyone is responsible. Yeah, then no one is responsible. And so how can you elevate data quality? Because for many of the users, they are using the system, the inventory, to do the day-to-day operations. selling new connections, for example, or restoring network connectivity. But when your data is not correct, you lose a lot of time, precious time, and that's all because of this bad data quality. So what is good data quality? How do we get there? The power of a digital twin. I heard my colleague say it needs to be accurate data, and indeed, data needs to be accurate, but for us, it also needs to be complete. In a telecommunication network, it's not only just the fibers and the cables and the ducts and the trenches, which are all underground and invisible by the cars of cyclomedia. It's a passive infrastructure, it's an active infrastructure. The data not only needs to be accurate, also complete, and lastly, up to date. What happens when you have accurate and complete data, but it's of a year ago, then in the end, your day-to-day operations will still be blocked by a lot of issues. So we try to have that 3 parameters into our definition of a digital twin. How do you get there? Well, for us, we need to have real-time data, real-time feedback from the network. So we feed a digital model to elevate data quality or to detect data quality issues, and doing that real-time feedback loop will really elevate the quality so it can be used in the day-to-day operations. And I have a few slides that are the most boring representation of a digital twin. For example, this one. On the left, you can see Ireland, and you see the cities and how every city is interconnected using active equipment for the telecommunication network. It seems a very stupid image, but this data is generated by the network. It's network-generated data. We probe the network. We ask each and every device, who are you? They respond. They say, who are they connected to? We rebuild the active model. We fit it to the physical network inventory, and that creates the accuracy, complete, and up-to-date information of the network. And this kind of data, while it's very boring, it's not sexy, it's not 3D at all, it really drives the operational excellence for the engineers. The same data can also be structured in another way. This is just the logical representation of a network, but just the fact that this data is accurate, complete, and up-to-date really makes it useful. And so for us, a digital twin, of course, is that digital copy of physical reality. Of course, you should be able to use it to simulate behavior, in our case, network behavior, what happens if you cut a cable. But more importantly, it needs, you can use it in the day-to-day operations because the data is up to date. And that's for us the key factor. And that maybe was also a question for my colleagues as well, is on that definition side, like this accuracy, complete and up to date, and how your organizations are working with that. Thank you.
Thank you. As promised, you have seen 3 different views about the digital twin. I have a question for Eric. My impression that you are considering the construction sector or building environment as a mature market. With the evolution of BIM, it is quite clear for me that we are ready for use these technologies. There are some challenges to be addressed, but how do you see the industry adopting the model of digital twin from your privileged observatory? And again, how you see the impact of the metaverse in engineering?
Okay, well, for the first question, BIM, again, I stress that it's a process, building information modeling, and it's a verb, not a noun. Yes, it's true, it was introduced into the industry in the commercial building industry, but probably 2 decades ago, it started to go horizontal as well. So think of roads, rail, utility networks, the like. It's a process to preserve that information and to hand that information over to stakeholders every step along the way of the life cycle, planning, design, construction, and finally operations, so that the owner of the asset has this information, this digital twin concept, to better manage the asset. So it's mature in the industry today. It's rapidly growing. And it's growing because we have to close this gap between demand and capability, and the way to do that is through technology. But BIM itself is not the solution, and that's why you heard me talk about additional convergence of other spatial data sets, like the conditions capture that my colleague here mentioned, in terms of going out and capturing real-world data. That could be inside the building, it can be outside the building on our highways. And we need to take all this information and allow it to converge. And the way it will converge and the interoperability of it will be in a platform-type environment, which is what you'll hear us talk about BIM next. So we're currently on BIM 2.0, which is this data management process with the right governance around ISO type of governance, and then you'll see it all happen in the platform very quickly. As far as the metaverse, listen, it's intriguing. Is it disruptive to the AEC industry? Maybe when it comes out of the gaming environment of today and starts using real information, because again, digital twins for AEC need to support the analytical analysis use cases of how you're going to manage that physical asset.
Thank you very much. Serge, I have several questions for you, but for the sake of time, I will try to combine. I have seen that you are clearly focusing on collection of the true-of-life imagery for the development, but as well you are mentioning the importance to address the exponential multiplication of IoT of sensors that will be connected to the future. And again, you need the technologies or services like SAM to process this amount of information. So how do you see the challenges to integrate this huge amount of information in order to make, I would say, operational digital twin?
So there are many steps between images or information that's captured or received from IoT devices or other devices and getting this into a usable sense. And I think what Eric was saying about the platform, yes, there will be platforms for different types of applications that will gather relevant information and help build these digital twins. When I'm looking at the way that the infrastructure, we're talking about infrastructure industry, infrastructure that is outdoors infrastructure, that's what we work with. There is millions and millions of pieces. We have one of our customers, recent customer, City of Milan. We captured imagery and they asked us to look at a number of categories of objects that they wanted to identify. All kinds of objects that are part of what the city manages. We ended up with over 190,000 objects, each of them with between 5 and 50 attributes. This is huge amounts of data that did not exist before. Milan did not know that they had these 190,000 objects. Now they know, and they will continue managing them. Getting to a digital twin from this means then connecting these assets between them, connecting them to workflows that help maintain these assets. So there's a lot of ingredients that are required. And of course, accurate data is key, as I was mentioning before. When we're looking at how the metaverse, which is also part of the discussion today, the industrial metaverse is emerging, there's lots of very interesting applications. NVIDIA has launched its Omniverse platform, where indeed you have data that can be put on that platform and used by the platform, by those who build applications on that platform. There's very exciting applications like the Heavy.ai application, which is a full metaverse 3D rendering of a 5G network and how the coverage of a network bounces off buildings, trees, etc. So physical laws, real life physical laws modelized in an industrial metaverse. This is coming. It's still in its infancy, but it's coming. And when we're looking at the efforts that all of us in the GIS industry are bringing to make this data available, to make the platforms available, I think that we still have a few years before we get to really kind of complex and large digital twins. But today, companies like Cyclomedia are already producing a full-scale super mesh, a mesh of a full-size city. So that is a 3D rendering of a full city, hundreds of square kilometers. So we're getting there.
Thank you. A question for Luke. Comparing to what has been presented by the other two panelists, you are not putting 3D visualization as a matter of priority for your specific applications. What do you consider are the main challenges in building a digital twin for the purpose that you have addressed?
For our users today, the 3D is not the requirement yet. They just need a basic good data quality. And I can imagine that we will connect the different digital twins that we are all building by relating the same objects, and other use cases will emerge by connecting, for example, the 3D city mesh data of Cyclomedia with network information we have for potential use cases for specific users at the operator. It's always about looking at what is the exact challenge and what's the best solution. And we are not at the moment going for that metaverse or wanting to integrate all that data. It will come from the market. If they need it, we will be able to connect all those information sets together.
Okay. Then I have a final question, and I will start with Serge. Which kind of metaverse you have in mind? So is metaverse for prosumers, for consumers, or is a metaverse for decision makers and policy makers? How do you see in the future development of the metaverse?
So the industrial metaverse, the metaverse for professional users is already emerging. As I mentioned, I gave a couple of examples. I think that so the metaverse versions for professional users have existed for a very long time. If you take an Excel sheet that has the balance sheet, the profit and loss of a company, that's a model. That's actually a model, a metaverse of a company. We are looking now at building industrial metaverses that are both indoor, outdoor, that are both infrastructure, processes, services, including real-time data. So this is emerging, and there is a lot of efficiency, a lot of effectiveness to be gained. Therefore, this will emerge. There's benefits that hit the bottom line for companies, and there's benefits that are seen by the users. They're faster, better at doing their job. One of the potential killer apps could be augmented reality, where you combine a model with true life images and with superimposing these to reality and helping operators in the field do their job faster, better. This is already existing. Now, consumer metaverse is another thing. Virtual reality hasn't taken off. We're all, I think, waiting to see the hype from Apple's release that will come in June. Let's see. For the moment, what we've seen in the consumer metaverse is not true to life. It is clunky. It is difficult to operate. It is not something where companies can see their workload go down, their efficiency go up. On the contrary. So let's see for the consumer metaverse. I'm not sure how fast this will come, but for the industrial metaverse, it is coming because there's very good gains of efficiency and effectiveness behind it.
Okay, thank you. We are out of time. Do you want to say something on this?
No, I'd just quickly say that I think it really depends on the use case. We've had digital twins, smart cities, and now metaverse around, and it really depends on the definition and the use case and the problem you're trying to solve. I see tremendous advantages in visualization and gaming type applications, but again, it has to have the intelligence, it has to be real data to solve real problems.
Okay, thank you very much. I think that we need to conclude the session because we are running out of time. And I think that this session demonstrates that we need more time because we have many more questions, but maybe we will have the opportunity to have further discussion. Thank you for all the speakers.